right, so on AA6-2, we are determining, based on the investigation we did in 6.1, we're determining the rules that are associated with those various polynomials. So, in a lot of these cases, and this is a really messy key, I used a much nicer version earlier in an earlier video, but it turned out it had no sound, so that was unhelpful. So I'm just going to show you in the investigation that we did last time. There's a few different things that we can point out. First of all is the relationship between the x-intercepts, -3 and +5, and the factor. So x plus 3 has an intercept at -3. The reason for that being, if we were to substitute -3 in for x, we would get 0, which means we'd get 0 for the whole thing. And whenever we're finding x-intercepts, we're looking at what x equals when y equals 0. It's the zero product property, essentially. We also are looking at starting and final direction with a big focus on final direction. So there's a few trends we realized there. Both of these first two have a final direction that is going up, and that is because our leading term is positive. Where we had a leading term that's negative, and I apologize for the messiness of this, we had a leading term that's negative here, and we ended up in a down direction. We also had a couple of different types of roots or x-intercept. Roots and x-intercept are used interchangeably. They're the same thing. We had bouncing roots where our graph came up to or down to the x-intercept, hit it, and then turned around. We also had flat roots where it went up and went flat briefly and then continued in the same direction. So a bouncing root changes directions at the x-intercept. A flat root continues in the same direction but just goes level for a short time, or nearly level. Mathematically, it's not completely level. So out of those different graphs that you did in the investigation, there were some definite trends and some patterns that are important to what we're doing this unit. So if we know the factored form of the equation, get a better pen, sorry. If we know the factored form of the equation, we know the values of the x-intercepts. If we know, so if the factor is x minus c to the n, I'm not looking at the exponent right at this moment, that part's not important, so I'm going to x out type, and we'll talk about that in just a minute. If I had x minus 2, that means I have a root at +2, because that's what creates my 0. So if I have x minus c, then I have a root at c. If I have x plus c, I have a root at -c for the same reason. If I have x to the n, so there is no plus or minus anything, that means I have a root at 0. If I have an even numbered exponent, so here I'm going to get rid of that. If I have an even numbered exponent, squared to the 4th, to the 6th, whatever, that creates a bouncing root. If I have no exponent, that creates a crossing root. And if I have an odd exponent, that creates a flat root. So what I know in this example, I went ahead and x'd out that -4 because we're going to deal with that later. What I know from this table up here and the ones I experimented with in 6-1 is that this x squared is going to create a root at 0, and because of that squared, it's going to be a bouncing root. The x minus 7 is going to create a root at +7. Because of that third power, that's going to be a flat root. And the x plus 4 is going to create a root at -4. There is no exponent, so that's going to be a crossing root. And if you take a look at this, the scale is severely modified, and it still goes way, way down and way, way up. Sorry for the glare. But my main concern is not what's happening with the y-axis, but we can see our hang on, I'm trying to get the scale back there. So this is our -4 root, our 0 root, where it bounces and turns around, and then our flat root at 7, where it goes flat and continues up. So that's on Desmos. That's what we did all of 6-1 with. And if you were not here, that's desmos.com. It's a very handy little tool for that. So if we know the degree of the polynomial, that tells us the maximum number of roots or x-intercepts. So this is a 1, 2, 3, 4, 5, 6 degree polynomial. It's going to have no more than 6 roots. If we go back to that, this one in fact only has 3 roots. Back to that screen. But this one right here, the crossing root, is just a single root. Where it bounces, that's a double root. And where it goes flat is a triple root. So we have 3, 4, 5, and 6. So that's why that works out the way that it does with that particular equation. But a 6 degree polynomial could have as many as 6 x-intercepts. The leading term of A tells us the orientation. And what I mean by orientation is the ending direction. So, on some of the graphs that we had last time, we had a positive number here that gave us an end direction of up. All of these on the second page actually gave us an end direction of up because our leading term was always positive. However, when we came back here, there's only that one that has a negative, and that ending direction was down. So anytime we have a negative leading leading coefficient, our end direction is going to be down, which makes our orientation considered negative. On the other hand, if we have a positive number for our leading coefficient, that is up for our end direction, which of course would give it a positive orientation. The even and odd part is a simple matter of looking at what's happening to our x values. So this was an odd number, so 1, 3, 5, or 7, and that had a starting direction of down and an ending direction of up. As I've said in previous videos, the down and up part really depends on what you're more comfortable with. I have increasing and increasing here because if we just look at our y values as we go from left to right, so increasing in the x values, our y values are increasing to start and they are increasing to end. So if you want to talk about the y values for your starting and your ending direction, make sure you're specific about using the terms increasing and decreasing. If you just want to use the arrows to talk about direction, this is down and up. If you look at the previous one, it's up and up. And if you look at the next one, it's down and down. So you can talk about it either way, whichever one makes more sense to you. But if you're talking about the arrows, use up and down. If you're talking about the y values, use increasing and decreasing. So what we notice about our different graphs is that when we have an even number for our degree, the arrows are pointing in the same direction. And if we have an odd number for our degree, they're pointing in opposite directions. So I'm going to be using up and down. You can use what you prefer in these. So for the even number, we were up and up. For the even number negative, we were down and down. Odd number positive, we were down and up, and then down and down. No, just kidding. Sorry. Up then down for the odd. And if you wanted to look at it in terms of y values, you can say decreasing and then increasing, increasing and decreasing, increasing and increasing, or decreasing and decreasing. And that depends on what makes sense for you. I'm not going to talk about these down at the bottom very much, except to discuss that a lot of these rules, especially the ones at the top, have to do with when we're in the factored form of the equation. And the only one that's in the factored form is this one. So this one would tell us that we have a negative orientation. We have a bouncing root at -4 and a fairly flat bouncing. And it would look something like that. The rest of these, we can't do a whole lot with them except for what we know perhaps from the graphing forms, because they're not in factored form. So, we're going to have a bouncing root, but it's not going to be on the x-axis, so I shouldn't even say it's a root. So on these, I'm not going to do the graphs of them because they're not in factored form, and I want to talk about those later. So on your 6-2 worksheet, practicing with polynomials, I'm going to take a look at this graph right here. So in all of these situations, you're given various parts of the polynomial. So this particular one, we're given the graph. So because of this graph, we know that we have roots at +3 and -2. We know the -2 one is a bouncing root, and we know that the 3 is a crossing root. Only 2 S's in cross. Sorry about that. Okay, so because we know those x-intercepts, or those roots, we also know the equation, or at least part of it. So we know that the factor for the root of 3 is x minus 3. Because it's crossing, we have no exponent. And for the -2, it's x plus 2. And it's going to be squared, or to some even power, because it's bouncing. We also know this is going to be a 3rd degree polynomial. We know it's going to be negative because of that ending direction right there. And my leading term would just be x to the 3rd. Sorry, negative x to the 3rd. So I need to add to a negative to that front of that equation. And my start and final direction is up and down. So in each of these cases, you have enough information to get you through to figure out the rest of it. And that's what we're working on. And that particular skill is going to be really necessary for 6-3 when we start finding exact equations. So hopefully that helps you out, especially if you missed that particular class. And sorry it wasn't a better video, but I didn't have time to make a full other video. So have a good day, and hopefully this gets you caught up.